Okay, hey class, Mr. Bean here. This is video uh, 13.3, The Fate of the Sun. All right, so on this one here, what we're going to do is we're going to discuss on this HR diagram how the end result of our sun will be. Okay, so I'm going to go ahead and go down here, and what we'll do is we'll start here in the middle. So we're going to start at the G, class G here, and let me go ahead and use go here, and we'll start here. I'm going to go up like this here. Let's draw y-axis. The sun is a yellow star here, and we're going to go here at 1 and go straight across like so, and just go right below the number 5 here. All right, so we're going to go ahead and use the color yellow, and I'm going to do pin here and see you get yellow. Okay, so the sun is right here. Let's go ahead right here is a middle-aged star, and it's a class G star. So here's the sun right now. And just for reference here, let me go to pin here. Let me see. That's uh, okay. Let's use black. Okay, so right now the sun is converting hydrogen into helium, okay, as we speak right now. So eventually, all the hydrogen will run out and the sun will end up over here, which is called a red giant. So go over here and let's kind of draw this a little bit bigger here. And this will be our sun. It is a what we call a red giant. It's not a super giant, but it's a red giant. So here, the sun is converting helium into carbon. Okay, so carbon is in the core of the sun right now when it becomes a red giant. So this is going to be red giant. So we'll go here and we'll put down here red giant. Okay, so red giant. Okay, all right. So all of this will occur roughly 5 billion years from now. Okay, so this is going to be about 5 billion years from now. Okay, the sun will have an expiration. Luckily, we'll all be dead by then. Okay, all right. Well, 5 billion years from now. Okay, all right. Okay, so the prom next year is okay. Okay, all right. Okay, so, anyways, what's going to happen is that it's going to run out of carbon. And what's going to happen is that the sun is not big enough to fuse carbon into anything else. What's going to happen is that it's going to transition into what we call a planetary nebula. So we'll go over here and put it here, black here. Okay, it's going to, okay, the fusion will stop. Okay, fusion will stop here during this process, and it'll end up over here as it's called a planetary nebula. So go over here, we'll write down planetary nebula. So planetary, okay, planetary nebula. Okay, so an example of a planetary nebula would be like M57, the Ring Nebula. So you may want to look that up on Google, M57. So it's going to be a planetary nebula, and what happens is that fusion will stop, and the star will collapse. Okay, star will collapse. Okay, collapse. Okay, like so we'll collapse here, and what's going to happen is that here we'll have the now this is a black, but it should be a white dwarf. But even though I have black here, it's going to be different colors, multicolors. So let's go ahead and put like a blue here around it here, like that. Maybe let's use some red in here. Get some red in here, multicolor like so. Let's get some green in here as well. Okay. Okay, so all right. So this would be what's called a planetary nebula. Now, so this white dwarf is like the size of the Earth, but with a mass of the sun. Okay, so we'll put in here size of the Earth, size of the Earth, but the mass of the sun. mass of the sun. Okay. Okay. Now, eventually, after all of this gas here dissipates, it'll end up becoming a black dwarf, which will be way over here. And this will be a black dwarf. So this will be the fate of our sun dwarf. All right.